Hello, everyone. This is the lecture for section 7.3, double angle, half angle, and reduction formulas. So I believe I said it in class, right? 7.1 was sort of how to play the game. 7.2, 7.3, 7.4 is just me giving you different parts of the game. That's it. Okay. The more important thing was 7.1, learning how to solve identities, use our trig identities to find different angles, and then how to use them in solving other trigonometric identities, right? Um, 7.2, 7.3, 7.4 is me just giving you more sort of well-known identities, okay? This one is going to be these three, okay? Double angle, half angle reductions, okay? So let me get into the very first set, just the double angle formulas, okay? These are it right here. So 1, 2, and let me actually do this in a separate color. I'm going to do it in blue because this one has three different versions. So cosine of 2 theta is either equal to cosine squared minus sine squared, 1 minus 2 sine theta, and 2 cosine squared theta minus 1. And then the last one, I'm going to do it in pink, tangent is equal to this. Okay. Okay. I'll prove these. I'll prove one of these in class, and they technically get all proved in the same sort of manner. You need the stuff from 7.2. That's it. It's a very easy application of stuff from 7.2. Okay. But remember, right? I'll do the proof in class. But it's not a big deal. That's not what I'm concerned with. I'm concerned more about you learning how to be able to use these. Okay. So let me go into an example really quick. Okay. Suppose we had tangent of theta, right? And theta is in my second quadrant, okay? So that's the upper left-hand side of the unit circle, right? I want to find all three of these. 1, 2, 3, okay? So how? Okay. For this, we're going to jump back into SOHCAHTOA. Okay, so I'm going to do my unit, maybe not unit circle, but sort of like that second quadrant, right? So here's BAM. Here's the circle. Tried to do a circle. There we go. Okay. So this thing is saying this, right? It's in the second quadrant. Here's my triangle, right? Okay. Tangent of some angle theta, right, is equal to opposite over adjacent, right? Okay. So we have that measurement. We know what that is. That's this thing, right? So I'm going to stick it in, right? So that means my opposite has got to be 3. And since that's vertical, it's upward, right? That's positive 3, which makes this negative 4. My adjacent is going to be negative 4, right? Okay. So then that means, right, we need to find this missing length. What the heck is that, right? So hopefully you guys see this coming, right? This is Pythagorean theorem, right? 3 squared plus a minus 4 squared is equal to 5. Oh, whoops. Well, c squared. I gave you the answer already, right? This is going to be 25 is equal to c squared. So therefore, c has got to be equal to 5. We found our missing length. Okay? Okay, so now you guys are thinking, well, that's great. And I forgot to put my theta as well. So here's my theta right here. Okay? So you guys are like, okay, that's great. That's cool. How do we find these things, right? So let me scroll back up to our formulas, right? The sine of 2 theta, cosine of 2 theta, tangent of 2 theta, right? If you look over here, right? These are all just theta, not 2 theta, right? So in order to make the sine, cosine, and tangent of 2 theta, they are now mixtures of just single theta, right? So long as we can grab our sine and cosine of one single theta from this triangle, right, we're good to go. And that's exactly what I'm going to do. So I'm going to do this. Sine of theta, right, So back to SOHCAHTOA, right? Sine of theta is opposite over hypotenuse. So this is going to be 3 over 5. And then cosine of this angle theta should be minus 4 over 5. Okay, so now we got everything we need. Make sure you have the trig trifold, the one with all the formulas on it. Okay, it's much easier to have that out in front of you, right, than to just keep scrolling back in the video. Okay, so A, sine of 2 theta is 2 sine theta cosine theta. And we're off to the races. We have both of those, right? So 2 sine theta, 3 over 5, negative 4 over 5. Okay, and if you multiply these out right, minus 24 over 25. We are done. That was it. Kind of becomes like a scavenger. B, cosine of 2 theta. Okay, this one was the one that had 3 different versions of it, right? Okay, you can use any 3, doesn't matter. Okay, but I'm going to use the one that has the mix of the 2. I'm going to use this one. Cosine squared theta, whoa, minus sine squared theta. Okay, looking at this stuff, right, it's going to be negative 4 over 5 squared, right, minus 3 over 5 squared. Okay, this is going to be 16 over 25 minus 9 over 25, 7. Done. Dunzos. Done, 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 done. Okay, and then the last one, okay, C. Oh, I need to switch back. There we go, C. We need tangent of 2 theta, right? This is equal to 2 tangent theta over 1 minus tangent squared theta. Whoa. All right, that's annoying. Okay. C. We need tangent of 2 theta, which according to our formulas is 2 tangent theta over 1 minus tangent squared theta. Okay, now we have tangent theta from the very get-go, so we didn't need to do all this extra stuff for tangent. Okay, this should be 2. Tangent theta is negative 3 over 4 divided by 1 minus a negative 3 over 4 squared, since tangent theta was given to us way up here. Okay, okay, let's simplify some of this stuff out. Yeah, we have now negative 3 over 2 divided by 1 minus 9 over 16. Okay, this is equal to negative 3 over 2 divided by, what is that going to be? 7 over 16? Yep, I like it. If you do this out, negative 3 over 2 times 16 over 7, negative 24 over 7. That's what it reduces to. Now, I gotta say this, right? Tangent is also equal to sine of 2 theta over cosine of 2 theta, right? So, if math was all right with the world, I should be able to grab these two and divide them, right? And look, lo and behold, there it is. So all of these work out. Like I said, all the methods, all the equations should sort of interconnect within themselves. It's not a coincidence that they all work. That's math. All of this has been proven. Okay? All right. I got a couple quick checks here for everybody to solve. Okay? We'll do these in class, obviously. Okay? Like I said, I'd much rather be able to have you all know how to use these trigonometric identities to solve more complicated things, right? And that's what I'm going to have you guys do, right? So, for example, I am rewriting here. Hopefully, you guys see. I'm rewriting here an identity, right? So tangent of 2 theta is also equal to 2 divided by cotangent minus tangent, right? Okay. So the same rules of the game apply here like they did in the past, okay? You want to grab either the left, turn it into the right, grab the right, turn it into the left, grab both ends and make them into a common sort of thing, right? Or reduce it all down to a common trigonometric identity, right? Okay. Hopefully you guys see the best way to do this one is to mess with that right-hand side. The right-hand side is the messiest side in this case, right? It's got more space to play with. Okay, so I'm going to try to grab this thing, 2 over cotangent of theta minus tangent of theta. And I'm going to try to turn it into tangent of 2 theta. Okay? Okay, so hopefully, if you want to, right? Just to get yourself some practice. I'm about to do it. I'm about to solve it, right? Pause it. Pause the video. Try it out. Okay? All right. So here we go, though. I'm gonna do it right now. Okay. So the first thing that I think hopefully everybody sees is I can just grab sine and cosines, or grab everything and change them to sine and cosines, right? That's fine. I'm gonna do sort of like one step before. Hopefully you guys see this, right? So cotangent is also 1 over tangent minus, I can grab anything I want and stick it over 1. Okay, so here we go. I am going to multiply by a 1. Here's one of those tricks that I mentioned, right? It's going to be a very nice one. I'm going to show you guys what I mean. 1 over tangent theta minus tangent theta over 1. I'm going to multiply it by tangent theta over tangent theta. So hopefully you guys see that this right here, that's 1 because it's something divided by itself, right? So that's got to be 1. Now, the reason why is because of this. I'm going to grab this and multiply straight across on the top and on the bottom, okay? Okay, so I'm going to actually write it out first of all. So it's going to be 2, when I multiply the top, it's going to be 2 times tangent theta, right? Divided by, I'm going to write it out really quick, 1 over tangent theta minus tangent theta over 1 times tangent theta. And I'm going to extend that top, the division. There we go. Okay. Now I'm going to do some distribution. Let me actually do it in the purple. I'm going to do this times this, and then this times this. Got it? Okay. 1 over tangent times tangent. Hopefully you guys see that's just 1, right? So let me write the top really quick. that's going to be 1. And then this right here, if you do tangent theta times tangent theta, that should be tangent squared. 1 minus tangent squared of theta. And if you can recognize this already, this is already, whoops, tangent of 2 theta. This was our identity. This is equal to this. So, and that's what we needed to get it equal to. So done. We are donezos. That's it. Okay. All right. What I got next is a couple more quick checks. I'm going to have you guys proving some stuff. Okay. Reduction formulas. Okay. This is used a lot in Calc 2. This is one of the things that when you get to Calc 2, you're going to need to have this sort of like on the tip of your tongue. Okay. They will make you use it like crazy. Okay. And the purpose for it is this. Hopefully you guys see what's going on. All of these are a power of a trig. So it's sine squared, cosine squared, and tangent squared, right? But what happens is this. They get turned into other trig functions. Hopefully you guys see that, right? But the power of the trig functions on the right-hand side is of power 1. So what we're doing here is we're grabbing powers, second power trig stuff, and turning it into single power trig stuff. It turns into double angle stuff, but that's fine. We reduced the power of sine, cosine, and tangent. That's what we wanted to do. Okay, that's what this thing is useful for. So if you can't mess with powers of trig, right, then what you do is you hit whatever expression you have with these reduction formulas, and hopefully the powers go down. Okay, so a real quick example of that is this right here. So let's say we have a cosine to the 4th x. They exist. It exists. Okay, and let's say we wanted to reduce it into a single power, where the power of all the trig stuff is just power 1. Okay. Okay. Here we go. So cosine to the 4th, right, is the same thing as saying this, right? Cosine squared of x, right, times cosine squared of x. Okay, I can split a power into 2 multiplications, right, where the powers just add up to the other power, right? In this case, 2 plus 2 adds up to the 4th power, okay? I have equations for both of these, okay? 1 plus cosine 2 theta over 2, 1 plus cosine 2 theta over 2. Okay? And if you multiply this out, right, I'm going to separate some stuff out. So I'm going to do this. It's going to be 1/4. I'm going to do it in big brackets. 1 plus 1 plus cosine 2 theta. Let me actually 2x, since I was using x's. It's very easy to switch to thetas when I'm copying stuff down. 2x. Put that one in parentheses. 1 plus cosine 2x. Done. Okay. Now, this right here is still a multiplication, so I'm going to multiply that out. Okay. You multiply it out, right? You get 1/4. 1 plus 2 cosine 2x plus cosine squared 2x. That's just foiling it out, right? Okay. Now, you guys see we have another cosine squared, right? So I can reduce that again. 1/4. 1 plus 2 cosine 2, oops, theta, not theta, x. Plus, just keep in mind how this goes, right? 1 plus cosine 4x all over 2. Bam. Let me put big parentheses at the front. There we go. This is it. So notice what I just did, right? I mean, and this does have a usefulness. Like I said, you won't see it until you get to Calc 2, more than likely. Okay? There it is. Okay? We grabbed something that was cosine to the 4th, right? And there is things in Calc 2, right, where we have no process of solving out something that is cosine to the 4th. We have no process to do anything with this, right? But in Calc 2, we do have a process for doing things of a single power of a trig function. Okay? So instead of messing with cosine to the 4th, we can mess with the bottom thing that I just wrote down. It's a lot longer. It's a lot big, right? But it's more manageable under the things that you're going to learn in Calc 2. Okay? Okay. Coming up, some more, what is this? Some more proofs verifying the identities. Okay? It's not bad. You guys saw what I did, right? Okay? Just follow along with everything that's already in the examples. Okay? Last set, half angle formulas. Okay? So I'm going to group them again, right? Boom. Cosine has just 1, and tangent has 2. It has those 3, sorry. That one and that one. Okay? Again, use the one that you need. Okay? And the other thing that I need to note is this down here at the very bottom, right? You guys see that all of these equations that are up above, right? The yellow, the blue, and the pink one, they have a plus or minus, right? We still have to be cognizant of where on the unit circle we are, okay? So obviously, right, sine and cosine have different values depending on what quadrant you're in, right? So just keep that in mind, okay? But in terms of using these, simple enough, right? So I'll show you guys what this is, right? So let me sine of 15 degrees. Okay, and actually I don't need much more space than that. I do want to keep the equations there. Sine of 15 degrees. Okay, and I want to use the half angle. Okay, so just so happens, right? I believe in one of your lecture questions in section 7.2, I think I make you find sine of 15 degrees, and that is sine of 45 degrees minus 30 degrees. Okay, so you can use the equations from 7.2 to find this out, right? But I'm going to use the half angle formulas, and it's as simple as you think, right? So this says, right? This says right here, I'm going to need this one. What angle do I have to divide by 2 to get 15? Hopefully you guys remember from kindergarten, literally from kindergarten, right? Sine of 15 degrees. That is the same thing as sine of 30 degrees divided by 2. Got it? So, bam, we need that one. Okay. This is going to be the positive because it's 15 degrees. That's in the first quadrant, right? 1 plus cosine of 30 degrees divided by 2. Cosine of 30 degrees is positive root 3 over 2, so positive. And this is legit. This is entirely correct. Don't think it's wrong because of what it looks like, right? 1. And did I use, yep, I used the wrong equation. You guys see that? This is supposed to be minus. Minus square root of 3 over 2 divided by 2. And we are done. That's it. Okay, so if you do this problem using this other method up here, you're going to get both of these answers. Like this is going to be equal to this. Got it? And that's how simple these work. You guys see how we are learning complicated stuff, but it's easier than people are making it out to be. Okay. After that, lecture questions. Whew, that was good. If there's any questions on the stuff that I just covered in here, ask me during our quick check time, or just simply come down to my office hours in the tutoring center. I will help you out. Okay. Besides that, happy studying.